Hey guys, welcome back to the MCAT grind. We have physics chapter 11, not really physics, but it's just about physics, about research reasoning, I mean. So, what is research reasoning? Well, these are the common terms you may see across different passages in regards to research in biological, chemical, anything when there's data being shown. Now, even data being shown, before that, they will ask about research methods. And speaking of research method, we have the finer method, which is to describe whether a research is feasible, interesting, novel, ethical, and relevant before you even start it. So this is the structure you want to have in mind when making a research proposal to enable the research being at least good. And we also have what's called a positive control and negative control. Control, as you know, is making sure to compare as a baseline against the experimental data. Positive control is when you expect a certain change to happen. For example, if you're trying to find out whether drowning negatively impacts someone, you want to have a positive control of drowning actually affecting someone who has gone through certain happenings of drowning and added effect, where negative control could be someone who has not gone through that process. So just a baseline, basically positive and a negative baseline for you to compare the experimental changes to. Independent variable basically is the variable you can manipulate, whereas dependent is only basing on the independent and changes upon the independent. And dependent variable is usually the one you measure and want to see whether it influenced by independent variable. Error can be defined as parameters of accuracy and precision. Accuracy, also known as validity, is saying how close you are to the true value. And precision is how close you are within each time you score it. So instrumental error, a systematic one, is usually caused by a measuring machine, which consistently does a precision issue. So that would basically instrumentally affect how close you are to a true value, but that can usually be fixed by adding a certain value each time. The random error occurs when you just do not have the control of it. For instance, randomly, perhaps one subject would just not have the ability to perform this test. Selection versus detection. If a selection error bias is when the experimenter chooses a non-random sample. So they may be keen on looking into a confirmation bias and thinking that only certain subjects have more likely to have this issue. They're not really doing a random sample instead. A detection bias is when they're looking for something more in a subject. So this can be solved using single blind and double blind experiment by making the experimenter and the subject not know what each other is. Observation versus confounding variables. Observation is what you can see, and confounding variables is like a third variable that's not between two variables. So it's not an independent or dependent variable causation, but rather a correlation instead. We also have human subjects, which is basing on random algorithm, blinding, and variables to help ensure a proper testing technique. We could also have a cohort, cross-sectional, and case control study, which are more correlational based. And when it's correlational based, we have less control of what variables to manipulate, but we could still validly look for patterns and traits. Hill's criteria describes what makes two variables correlate with each other and turn them into causation instead. If temporal value, time, if one variable always occurs before another, that highly suggests that it could because of causation. It's necessary, but it's alone not sufficient. You need to look at the strength and the dose and whether it consistently occurs over time and time again. If not, then Hill's criteria is not satisfied, then they could still just be correlation instead. we could also have the ethics in research. Beneficence, non-maleficence, autonomy, and justice are necessary in along with Hippocrates' oath, right? Do no harm. Basically, just like how research is in like three big things, we have to ensure that we want to do in the best interest of the subjects, and we're not doing any extra harm. Justice, make sure everyone's treated equally and in the similar treatments. And autonomy, we ensure that they have informed consent. We also have external validity, which describes things as statistically significant or clinically significant. Statistically significant could just be less than the p-value, and that we can successfully reject the null hypothesis, which we'll describe in the later one. But the clinically significant, if you change the drug by this minuscule amount, that's not going to affect the result of the patient. So we may have to consider that it's also not only statistically, but also clinically significant. All right, that's pretty much it.